Well, hello. Hi. Hi, CP Math 1. This is Mr. Roberts. We are well into chapter 4 now. And the big idea that I've been talking about every day pretty much since we've been in this chapter is that sometimes we collect data. We collect two numbers on one event. And when we do that, we get what's called bivariate data. And this is a nice data set that perhaps could model such a situation. You can see that I've got a lot of points here that are plotted in red. Every single one of them has an x value. This first one has an x value of 2, and it has a y value of 3. This has an x value of 2 and a y value of 5. Here, x is 4, y is 7. X is 5, y is 9. You see all these points, right? X is 6, y is 12. This one way over here, when x is 8, y is the number 15. What we want to be able to do is describe with what we'll call a mathematical model. A model is just a device that we use that helps us attempt to forecast what is going to happen in the future. And if I wanted to build a model, um, one of the things I might use it in terms of forecasting is like I can see like if x is 8, what I expect y's to be. Y's are going to be somewhere in this area from 13 to 16. This particular y, right, x was 8, y was 15, but I can see based on the randomness in some of these dots that I can't assume it's always going to be that. So it's going to be somewhere in here. If I was to extend out and say to myself, hey, I wonder what y would be when x is, for example, 50. So you can see x is 9 here. When x is 50, what do I think y would be? Well, to do that, what we like to do is kind of pick a couple of points that seem reasonable. And you can see like this would be a bad 2 points. This is not a good description. For one thing, the slope of this black dotted line doesn't really match the slope of what I see happening in the data, right? Um, this is clearly wrong. This is going the opposite direction. On the black dotted line, as x values get larger, right, we can see the y values are getting smaller, not what's happening in the data. So the data is doing something along this in terms of slope, right? This right here looks like it's matching about the slope, but probably the wrong y-intercept. So this is not a bad description of what's happening in this small data set, right? I can see that in general, the line's kind of going through the majority of my points, and it has kind of, if I squint and look at it, it has a y-intercept that does an okay job of describing what's going on. Well, when I settle upon a couple of points that I think are good descriptors of the model, right, at that point, I can come up with the equation of the line that will let me see what's happening. So if we take a look at this, now that I've decided on the 2 points that I think define a line that fits the data, I'm going to come in here and write down the coordinates of those 2 points. So it appears that this first point I selected was where x was 1 and y was the number 2. So you can see I've got this ordered pair. I've got an x value, comma, the y value. And the other point that I'm going to select is way up here at the top. And on this point, it appears that x is 8 and y is 16. So let me write that down right here. X is 8 and y appears to be the number 16. So 2 points that are defining this line. Well, now that I've got 2 points, right, we have some practice with this, and we're going to practice it some more, coming up with the equation that of the line that goes through 2 points. And in order to come up with that equation, we need to know 2 pieces of information. We need to know what the slope of the line is, and we also need to know what the y-intercept of the line is. And if we know those 2 pieces of information, slope, we use the variable, or we use the letter m to represent that. It's one of our 2 parameters. And y-intercept, we use the letter b to represent that. If we know our slope parameter and our y-intercept parameter, we can write the equation of this line. The equation would be in the form y is equal to m times any x and then plus b. So let's find, first of all, our slope, and then we'll find our y-intercept. I'll remind us that the slope of any line is how much y changes, how much the y-coordinates change, divided by how much the x-coordinates change. My y-coordinates in this situation are 16 and 2. And my x-coordinates in this situation are 8 and 1. So we can come in and we can write, let's do the change in y. I'm going to go ahead and take, that's going to equal 16 minus 2. So you can see I've just conveniently, this time I'm going from the point in my upper right corner and I'm subtracting the 1 in the lower left. So 16 minus 2. And I'm going to go ahead and do, for my change in x, I'm going to go ahead and do 8 minus 1. 8 minus 1. So my change in y is the number 14, and my change in x is the number 7. So the slope of this line appears to be the number 2. My rise is 2, my run is 1. Again, 16 minus 2 is 14, and 8 minus 1 is 7. So that's why I've got this 14 over 2, or 14 over 7, which equals 2. So I now know one of my two parameters. I know the slope parameter. What I need to do now is find the y-intercept parameter. And to find that, I simply pick one of my 2 points. It doesn't matter which one. I'm going to pick this point up here. And I'm going to use 2 things from that point. I'm going to use its x value and its y value. And I'm also going to plug things into this equation, y equals mx plus b. So I'm going to take this value of y, which is 16, and write it down. That's y equals. Now I need to write down the value of m, which is 2. Now I need to write down the value of x, which is 8. And then I need to write down plus b. Well, guess what? 2 times 8 is the number 16. So I get 16 equals 16 plus b. If I take away 16 from both sides, I see that, oh, 0 is b. My y-intercept is b. So the equation of this line of best fit ends up being y equals 2 times x plus 0. And that's it. We're going to practice this several times today. We're going to do that in Microsoft Forms. And if you're having struggles with this or you have questions, please see me today in office hours starting at 2 o'clock. This is Mr. Roberts. Have a great day.